Module 3 review, solving an equation for x. We use a simplified fraction if necessary. And the nice thing about this is we can use the calculator to do most of these, most of the calculations. Some of it we may not need, and that'd be all right. But in any case, I got to use principles of equality. So remember, principles of equality, if I do it to one side of the equal sign, I got to do it the other side. So I kind of set it up like this, right? So the equal sign is represented with this line. And over here, I want to isolate my x's first. So I want to be able to drop this 5/6 x without the minus 6. I don't want that minus 6 right there. So I'm going to have to zero that out by adding 6 to both sides. Okay. Why add 6? Because negative 6 plus 6 right there as a term gives us 0, which is what we want. So now we have 5/6 x, and I got negative 8 plus 6, and you can put this in the calculator if you need to. It is negative 2. Then I got 5/6 x. Remember, we don't want 5/6 of an x. We want 1x. 1x. Remember, we just usually make that a phantom 1 right there, right? So x would be equal, and then that should finish the problem. So how do I make a 5/6 a 1? Well, you could do this in 2 steps by multiplying by 6 and dividing by 5. However, if you just take anything and divide it by itself, then you should get 1 right there. See that? 5/6 divided by 5/6 is 1. It's just, since I did that on the left side of the equal sign, I got to do it on the other side. I'm showing the division differently, and hopefully that's okay. Wouldn't necessarily have to on the calculator here, but I'm going to. Negative 2 divided by 5/6. Like I said, at this point, you could do this by hand by reciprocating the fraction and changing the operation to multiplication, but I'm just going to use the calculator to do it. That's negative 2 divided by fraction button 5/6. Enter. And I got negative 12/5. Yeah, it says use a simplified fraction as the final answer anyways. So that's what I'm going to do. I'm going to keep this as a improper fraction. And this is good to see because it did say, well, use a simplified fraction if necessary. So it specified that it wants a fraction, not a mixed number. And then that may not sound very specific, but that's what it will say on the assignment 2. So that's what it's going to want. If it wants a mixed number, it will usually specify that. If it doesn't specify, then usually it will accept both. You could check this by replacing x with negative 12/5. I'm just going to use a calculator to do that because you don't necessarily have to write it out by hand. But I'm going to check, though, because that's good practice. So I got this typed into my calculator. When I push enter, I should get negative 8, and I do. So that one checks off. And you should always do that, especially if you're looking at a quiz or some kind of test. Always make sure to check because you can see that it didn't take very long. And if by chance on my calculator I pushed enter and it didn't give me negative 8, then I would have to go back and either check how I typed it in or just check the work here. But we're good on this one. So here we go. X minus 19/5 equals 2/5. And yeah, we're going to simplify the fraction if necessary. But we'll show the answer as a fraction. Now, this one's nice because it's already got a phantom 1x right there. There's a 1. It's just a phantom 1 right now, and that's good. But I don't want the minus 19/5, right? So I'm going to take this, I'm going to drop my x, and I'm going to zero out that negative 19/5. How am I going to do that? Well, it's negative 19/5, so just add 19/5. Boom. Okay. But if I do it to one side, I must do it to the other side as well. So adding 19/5 to the right side. The denominators match on this one, so I'm not too worried about using the calculator on this one. I'd have 2 plus 19 in the numerator, though. That'd give us 21/5 right there. And sure enough, that's already a simplified fraction. I know that can be simplified because they don't have any common factors as products anyways. And so let's go ahead and replace that, though. I'm going to just check in my calculator. 21/5. 21/9, but 21/5 minus 19/5. When I push enter, I should get 2/5, right? Boom, there it is. So that checks off. And then I would know that x equals 21/5. That's a nice one-step equation to get us started here. Oh, here we go. Yeah, we've seen stuff like this. All right, so in doing this one, of course, you can do this one all the way through by hand, essentially. And if I did that, I know that you don't necessarily have to do it. You could just use the calculator to just punch this in, but I'm going to just start with my numerator and see if I can simplify this, okay? Now I got the 1/8. I know 8 is a multiple of 4, so I'm going to keep my 1/8 1/8. Talking about the denominators there in the whole numerator for this complex fraction. But the 1/4, I'm going to change that 4 into an 8 by multiplying it by 2, and then I would have matching denominators. See that? So I'm going to multiply the numerator by 2 as well so that it maintains the same value in the fraction. And then for this numerator here, I would have 2/8 plus 1/8. Of course, the denominator is going to stay the same, so that's still going to be in eighths. I just got to figure out the new numerator. So that's 2 plus 1, which is 3, 3/8. And that fully simplifies the numerator for us. But what about the denominator? Yeah, it's going to actually work the same way. We're going to multiply the 4 by 2 to match the denominator of that 1/8 right there. Still subtraction, but that would give me a new denominator of 8. Some of you would just say, well, I know 1/4 is 2/8 because we already did that, and that'd be fine. I'm just kind of showing more work perhaps than I need to, all right? So that's 2/8 minus 1/8, which is not going to change the denominator, still an 8. And then in the numerator, I would have 2 minus 1 now, which is 1/8, okay? And at this point, I mean, if you haven't put in the calculator yet, then you could, I don't know, the setup here isn't too bad. You can actually take your 3/8 and show the division, just because it's not really too bad, divided by 1/8 right here. And here's why this isn't too bad, because the 3/8 isn't going to change, right? The dividend doesn't change, but if I change this to multiplication, then I then get 8 over 1, like this. And then if you cross simplify the 8's, because they're both divisible by 8, then you end up with 3 over 1, which, as it turns out, is just 3. And that'd be your final answer right there, okay? Which is kind of weird when we're in a fractions unit to see a whole value answer like this one. But it does happen from time to time. Now, did you have to do all the work that I just did right there? Of course not. But remember that you should be able to show some work, at least in the future, because we won't always be able to just, or have to do this on Canvas, okay? Another equation for us to solve, and this one's nice because it should only take one step to get to where we need to be, which is just x equals, right? Remember, we want this to be x equals that phantom 1. We want that coefficient of x to be a phantom. Remember, the coefficient is the number being multiplied by x. It's there. It's a phantom 1. You just can't see it. So how do I make that negative 8/9 fraction a 1? And just divide it by itself, right? That'd be divided by negative 8/9. And that is division, even though it's shown as a fraction. Yeah, anything divided by itself is a 1. So there's our phantom 1. But if you do it to one side, you got to do it the other side. So 6 divided by negative 8/9 as well. Okay, and again, I'm showing that division a little differently. So let's move this over so we can see it. So in my calculator, that's when I'll do the work here. 6 divided by negative 8/9, and you're welcome to do that by hand if you'd like, but this will do for me. And yep, this one, the calculator will give us the fraction directly. It shows as negative 27 fourths. But I'll just type this into the calculator just to make sure that it's correct with negative 8/9. And then that'd be multiplied by, I'm using parentheses now, negative 27 fourths, right? Close parentheses, enter. Yep, we get 6 when I push enter. So yeah, that would be the solution to this equation right here. Here's another complex fraction, and remember, it kind of goes back to that other complex fraction we did. So I'm going to take this complex fraction here, and I'm going to show it with a formal division sign, right? So that's 16/20 now divided by 12/9. Okay, but we don't really want this to be division. We never really divide fractions. We only multiply them. So that's 16/20. I can change the operation of multiplication by reciprocating or flipping that divisor fraction. So that'd be now 9/12. And I know some of you are looking at both fractions like, hey, can't we just simplify these? Yes, you can. You could have simplified them way up here, in fact, or right here. But let's say that we didn't notice that because you don't necessarily have to. Then I can see that 16 and 12, they're both divisible by 4. 4, and 12 divided by 4 is 3. All right, and then I see the 9 and the 3 there. Yeah, they're both divisible by 3. So 9 divided by 3 is 3. 3 divided by 3 is 1. And this is coming out pretty good for simplification. The 4 and 20 can be simplified as well. 4 and 20 are both divisible by 4. 4 divided by 4 is 1. 20 divided by 4 is 5. And, well, let's just put this in. Enter. Well, I guess not really enter, but we just need to actually do the work here. 1 times 3 in the numerator is 3. In the denominator, 5 times 1 is 5. Now, that's kind of a long process right there with that cross simplification stuff. Thank you, calculator, for confirming that we've done the work correct. All right, evaluate, use a simple fraction if necessary. Like I said, right here I'm going to do probably more work than you'd ever necessarily need to show, but hopefully it helps, okay, because technically you can just kind of type this one into the calculator. So I'm going to start first just with the first two terms here, that 4/7 minus 2/5, like this, okay, and if I can simplify these, then whatever I get from that difference right there, that subtraction, I just need to remember that I'll need to add the 5/7, okay, so whatever I get from this difference, I'll just plug it in right here, all right. So remember that we are subtracting fractions, and so I need common denominators. I'm just going to use the trick, even though it's going to be the lowest common denominator anyways. So I'm going to take the 2/5, the 2 and the 5, numerator and denominator, just multiply them by the other denominator, the 7 right there, okay? So that fraction then would become 2 times 7 in the numerator, 14, 5 times 7 in the denominator, 35. And then the 5 denominator, I'll multiply the 4 and 7 by the 5, okay? And we see that that gives us common denominators right away. Remember, it's not necessarily required when you're doing this type of work to have the lowest common denominator. We just need common denominators. So 4 times 5 in the numerator is 20. And now when I subtract with common denominators here, I have in 35ths, 20 minus 14 in the numerator would be 6. 6/35. So then I get 6/35 plus 5/7. And yeah, we can change those denominators to match. All right, now I don't really need to multiply the 6/35 because 35 is a multiple of 7, so I'm not looking to simplify that 6/35 right there or to scale it, but I will scale the 5/7 by multiplying the 7 by 5 gives us a new denominator of, well, 35. Okay, but multiplying the numerator, 5 times 5 is 25, and now I have matching denominators, which is what we wanted, at least doing this by hand. So I'm still in 35ths with the denominator. I just got to add the two numerators together. 6 plus 25 is 31. So 31/5. I'll do a better 3 than that. 31. There we go. 31/5. Okay? Now I'm going to check with the calculator, though, just to make sure I did all my work right by hand. Simplify this one as much as possible? No problem. We can do this with order of operations stuff, which is all we're really looking at this. First operation in the order of operations is parentheses. But within both parentheses, we already have fractions. There's no operations within either set of parentheses. So I'm going to skip the parentheses and go straight to exponents, which we have this exponent of 2, right? 3/4 to the power of 2. Now, it's not negative 3/4, and it's the parentheses that's to the power of 2, not this negative. That'd be multiplication. That's a later operation for us, okay? So I'm going to expand the 3/4. I'm going to show it with its repeated operation, 3/4 times 3/4. Yes, you could have used a calculator, and that's fine, but in the numerator, I'd have 3 times 3, which is 9. In the denominator, I'd have 4 times 4, which is 16. I almost put the 4 there. And you can keep that in parentheses if you like. You can show the negative now. It's up to you. I'm going to keep it in parentheses. What the heck? So that now is plus 8 times 3/4. Be careful because some students, especially with this unit where we've seen a lot of mixed numbers, that see this as 8 and 3/4. No, this is got the multiplication because of the parentheses right there, okay? So that's all of our exponents. Let's go now to multiplication and division. And yep, like I said, there is multiplication right here. By the way, for this particular part of the problem, I'm pretty much ignoring the negative 9/16 right there, okay? But the 8, I'm going to show it as 8 over 1 so that I can multiply these fractions. And I see that the 8 and 4 can be cross simplified because they're both divisible by 4. 8 divided by 4 is 2, 4 divided by 4 is 1. Okay, and again, I'm showing more work here than you'd necessarily need to. You could have just plugged that part in the calculator. Here's what we get though. In the numerator, I've got 2 times 3, which is 6. And then in the denominator, I've got 1 times 1, which is, well, 1. Okay, so that simplifies that part of the problem. Of course, we still have this negative 9/16. So, okay, and yeah, it's plus 6/1. Now I'm going to keep the 6 over 1 as 6 over 1. Some of you would perhaps change that to 6, which would be fine. I'm not going to because we're still dealing with the fractions on this, okay? And in fact, at this point, I do want to get rid of the parentheses just so that there's no confusion on what the heck that 9/16 is. It's negative 9/16, okay? And I probably should have said this, but and I think we've done this in the past where you could have shown this as negative 1 times 9/16, which really just makes the fraction negative. It's up to you how you look at it. You could have used a calculator to do that as well. So I need common denominators before I add these two fractions together. It's the 6 over 1 that I'm looking at. I can make that denominator 16 by just multiplying it by 16. It's just if I do that, I got to multiply the numerator as well by 16. So that's a denominator of 16. In the numerator, 6 times 16, that should be 96 right there. And it's kind of early, so I could have done that wrong, but the calculator should confirm that. So now I have negative 9/16. Try to match that. Negative 9/16 plus 96/16. Okay? And now that the denominators match, I'll just show this in 16ths. But the numerator, I'd have negative 9 plus 96, which should be 87. That's positive 87 right there. Okay? Now, could this be simplified? I don't think it can, because 87 is not divisible by 2. We can check, though. 87/16, just with the calculator. Nope, it says it cannot. And again, we can use the calculator to just double check that as well. So yeah, the calculator confirms that we've done this work correct. It took Barbara 3 5/8 hours to fly from city A to city B. Then it took her another 2 3/4 hours to fly from city B to city C. All right, so in this flying, she's got 2 different legs on it, right? A to B first. So I'm going to write this out. A to B, and then she will fly from city B to city C. So let's see how long it took her, though. From A to B, it says it took her 3 5/8 hours. And then from B to C, it took her 2 3/4 hours right there. Now, it's asking how long it took her. It didn't ask. It's asking how long it took overall. I know it doesn't say that, but it should. Okay, so we're going to add these two together. That's going to tell us how long it took her to get from city A to city B to city C, or just how long she was flying in total. It can be phrased either way, by the way, on this assignment. Okay, so you could just type these into the calculator, but I'm going to actually show the work on these. So with some cycle method, I can change these into improper fractions. It's kind of our first step in solving these with mixed numbers. So I'd have first 3 times 8, which is 24, and then add the 5 numerator, which is 29. Remember, the denominator is not going to change, so that's 29/8. And then in the numerator, cycle method as well, or the second number rather, that'd be 2 times 4, which is 8, and then add the 3 numerator, which is 11 in fourths. Okay, we're going to add these together, but we can't add those together until the numerators match, so we'll need a little bit more space here. And I know 8 is a multiple of 4. So 8 is a multiple of 4, and so I don't necessarily need to change the 29/8. Okay, I can keep that as 29/8. But I can change the 11/4 by just multiplying the 4 by 2, and that will match the denominators as 8s. Okay, so now they're common denominators. I just need to multiply the numerator by 2 as well, so I do not change the value of the fraction. So that's 29/8 plus 22/8. So So now that our denominators match, I know that I'm going to get some number of 8s. I just got to figure out how many. So that'd be 29 and then plus 22 right there. So that's 51. Okay. I know I didn't show all the work there. Again, you can do that in the calculator. 51/8. And where this one didn't specify what type of answer it wants, either as fraction or mixed number, you could say that this one is the answer. Of course, if it didn't, then I would just say I would stop there myself. But for those of you that prefer to see this as a mixed number, which is okay, just be careful even in typing it into the calculator, because as you've seen, even I can make mistakes on the calculator. Okay, so but I use the calculator to change this into a mixed number, and it gives me 6 3/8. Of course, that's still being hours right there. So I'm just going to put or on this one, just so we know that this particular problem did not specify how it wanted the answer. So we'll just show both on this one. The recipe calls for 3 1/3 cups of sugar. How many cups will you need if you're preparing 4 batches of the recipe? So this goes back into really the definition of multiplication, right? It's like saying you got 4 groups of this 3 1/3 right there. And so this multiplication, you could have just put multiplication between the multiplication symbol there. It's up to you. Same thing, okay? But I don't really want to multiply with a mixed number. I mean, you're welcome to if you'd like. I'm going to use cycle method to change this 3 1/3. So that'd be 3 times 3, which is 9. And then add the 1 numerator there, gives us 10. That's in thirds, so 10/3. But this is all multiplied by the 4. In fact, I'm not just going to show it as 4. I'm going to show it as 4/1, so that we can see this is fractional multiplication. I don't see any simplification that's possible right here, and so I can just multiply the numerators together. 4 times 10, which is 40, and then in the denominator 1 times 3, which is 3, right? Now, of course, again, this one didn't say if it wanted the answer as a mixed number. I'm going to assume that it does because it gave us a mixed number in the problem, okay? So 40/3 cups, it could work, or you could change this into a mixed number. I'm going to skip the calculator on this one just to save us a little bit of time. That should be 13 1/3 cups, okay? And then, of course, now that I've done this by hand, oh, I forgot to show the 1 times 3 there. There it is. I'm going to type this into the calculator just to check. You could have used long division to change that improper fraction to a mixed number. It's up to you, but the calculator is a valid method as well. All right, another order of operations problem for us. No problem, though, for us, though, right? So we're going to start with parentheses because that's the first operation we should always be looking for in an order of operations problem. And yes, there are operations within the parentheses. So we're going to focus on just what's within the parentheses here, okay? That'd be 2/7 plus 1/14. And I see that 14 is a multiple of 7, so I can just multiply the 7 by 2, and that would give me a denominator of 14. I just need to change the numerator as well. Correspondingly, 2 times 2 is 4. So 4/14, that has the same value as 2/7, which is exactly what I wanted. And now the denominators match, right? So from this, we get a denominator. The denominator is not going to change with this addition now that they match, but the numerator 4 plus 1 is 5, 5/14. Okay. So now I got the parentheses, but I've simplified the parentheses into just the 5/14. Yeah, that should be 5/14 right there, not 5/4. So let's make that 5/14 times 2/7. Yeah, and still simplifiable though with the 2 and 14. They're both divisible by 2. 2 divided by 2 is 1. 14 divided by 2 is 7. There we go. And now we know that we got 5 times 1 in the numerator. That's 5. In the denominator, 7 times 7 is 49. And again, that's the nice thing about checking with the calculator is it told me that I had made a mistake somewhere, either in the typing or in the work. And sure enough, yeah, I copied down the 14 as a 4 right there. And so this one's already been confirmed with the calculator. We already know the answer is 5/49. So perform the indicated operation and simplify. Yeah, we got 18 minus 9 and 7/18. That could be pretty rough. No worries though. So I'm going to use cycle method to change this 9 and 7/18. Whoops. Into an improper fraction. Of course, it'll still be an 18th here. But then I would have, where am I going to do my work here? 9 times 18. I don't know what that is. Maybe some of you do. Whoops. But I'm using the calculator to do that. 9 times 18 is 162. And then add the 7 there. Makes that 169/18. Of course, you could have just used a calculator to do that. But now it's 18 minus 169/18. And yes, I will show the 18 is 18 over 1. I just need the denominators to match, right? So I'm going to multiply the 1 by 18. And yeah, that'll make the denominators match as 18s. I just need to multiply the 18 by 18 as well. So let's see, let's do 18 times 18 in the calculator because I don't want to do it by hand, and hopefully you don't either because we can use calculators now. 324 right there. Still minus in 18ths. Use the same color in 18ths. 169. So now that the denominators match, they should still match when we do this subtraction. And I can just go to the calculator to do the subtraction. 324 minus 169, right? Subtracting the numerators. 155 over 18. Now, 155 is not divisible by 2. It's not divisible by 3. So that should not be simplifiable, but we can use the calculator to check. And I'm just going to use the calculator to convert this, by the way, into a mixed number as well, because this one, once again, it didn't specify, this problem did not specify if it wants it as a mixed number or an improper fraction. So I'm going to show both, which means usually that either one would work, right? The calculator, once I type the answer in, or the original problem into the calculator, gives us 155/18. But using the calculator to change this into a mixed number, it gives us 8 and 11/18. Now, like I've said before, though, I would have stopped here, just because, even as you've seen, I've been able, I sometimes will even type this in incorrectly in the calculator, and so where this one didn't ask for a mixed number, I probably would have just kept it like this. And also, again, on the assignment, it should accept either one of those. Perform this operation, just addition of these mixed numbers, no problem. I'll use some cycle method to change these into improper fractions. So 6 times 6, which is 36, plus the 5 numerator makes that 41. That was a 36, by the way. 41 sixths. And then over here with the 2 times 8, that's 16. And then plus the 7 numerator makes that 23 right there. Yeah, 23 eighths. So this is my new problem, 41 sixths plus 23 eighths. I just need the denominators to match, right? So without finding the lowest common denominator, because it's not necessarily needed, I'm just going to take the 6th denominator multiplied in the numerator and denominator of the second fraction, so multiply it by 6. Gives us a new denominator of 48. 23 times 6, 120, 138 right there. And then over here, I'm going to take the 8 and multiply it by the numerator and denominator of the first fraction there. So that'd be a denominator 48, that forces them to match. And then in the numerator there, that'd be 328. You can check in the calculator, it should be good. And so I'm going to add these together. If I made a mistake, we'll see that, by the way, which would be okay. So I'm looking at 48. I got 328 plus 138. There we go. I can't do that one in my head. 328 rather. Plus 138. Enter 466. Okay, so 466 48ths. And this is what I get just by hand, but I'm going to use a calculator to simplify this. I know they're at least divisible by 2. Maybe 4. Not just 2, looks like. because the calculator, when it simplified it, it gave me 233/24. Okay. Now again, this one did not specify if it wants the improper fraction or the mixed number, so I'm going to show both. So there's our improper fraction. For those of you that want the mixed number, the calculator gives us 9 and 17/24. So I just kind of simplified that last answer, 466/48. But I'm going to use the calculator to check the actual, all of the work there. So the calculator confirms that we've done this correct both ways. All right, now we got division with these mixed numbers, and that's no problem. Again, it didn't specify that it what type of answer it wants, so we're going to show both. And yep, I'll start by changing both these into improper fractions with some cycle method. Okay. Now this is -2 2/3, so I just know my answer is going to be negative. It will still be in thirds, by the way. But for the new numerator, I would have 2 times 3, which is 6, and then plus the 2 there would give us 8. -8/3. Now we'll do the same thing with -5 3/4. Once again, the fraction will be negative, so there's my negative sign. Then I've got 5 times 4, which is 20. Then add the 3 numerator, makes that 23/4, right? Because the denominators don't change. This is division. We don't really want division with fractions, so I'm going to change the operation. That means that -8/3, there the dividend will stay the same. But I can change this operation to multiplication, right? By flipping the fraction. Now remember, it doesn't change the sign. It's still negative, but now it's just 4/23. And really at this point, I don't see any cross simplification anyways. So I'm not going to try any. So this is going to be from, well, the sign of the answer here is going to be negative times a negative is a positive. That's good. But then in the numerators, we got 8 times 4, which is 32. And then in the denominators, 3 times 23 should be 69 there. Okay. So this would be our proper fraction. Of course, we can't even change this into a mixed number, so that should be our final answer. Let's just double check on the calculator. So the calculator confirms that we did this correct, and there's our answer. All right, I like these types of problems. It just says write this as a mixed number, and so that's what I'm going to do. I just remember that the mixed number here is going to be in sevens, right? I just need the whole value in the numerator. And we can do this with long division. Of course, I know some of you would just do it in the calculator, and that's fine if you do. What is that? 60 divided by 7 right there. Okay? So 7 won't go into 6, but it will go into 60 8 times. 8 times 7 is 56. So when I subtract this, it will give me the remainder, which will be the numerator of the mixed number. And that's going to be 460 minus 56 is 4. So the quotient is 8. And the remainder was 4, so that's our numerator right there. And just as usual, like hopefully we're getting used to, I can take to the calculator now and just double check to make sure that I've done this correct. So the calculator confirms that we've done this correct. All right, here's a problem. You could call this order of operation, but it's just addition throughout, right? 6/4 plus 5/8 plus 3/16. And for those of you that see that the 6/4 can be simplified, you're welcome to simplify that if you'd like. I'm not going to because, I don't know, not everyone would notice that, okay? But remember that really what I would like to do is just find the sum of 6/4 plus 5/8. Okay, once I get that value, then I can add my 3/16, just as we've seen with the previous example. So I take the 4 and multiply it by 2 and 6 times 2 as well. That will give me matching denominators in eighths. 6 times 2 is 12, so 12/8 now plus 5/8. Yep, that's going to give me a new fraction in eighths, but the numerator is 12 plus 5 is 17. 17/8. Okay, so then my new problem becomes 17/8 plus 3/16. But once again, since we're doing this by hand, we're going to need matching denominators. 16 is the second multiple of 8, and you can see that would then give you 16ths. But I have to multiply the 17 by 2 as well. 2 times 17 is 34. Now plus 3/16. I need a little bit more space here, but not too bad. Final answer will be in 16ths, and I have 34 plus 3 in the numerator. That'd be 37. Now that shouldn't be simplifiable, and well, you could change that into a mixed number if you'd like. It's not required that you do because it didn't say that it wanted a mixed number, but that'd be 2 and 5/16. Okay, but let's use the calculator just to double check our work. So the calculator confirms that we've done that correct. Either one of these will work. All right, perform this indicated operation and simplify. This one shouldn't need a mixed number in the end, but we do need the common denominator thing, right? So 20 is not a multiple of 8, which means I'm just going to use the method of multiplying the denominator into the other fraction. It's not going to be fully simplified, but that's not a problem because we can have the calculator simplify for us, right? So in the numerator, then I'd have 20. In the denominator, 8 times 20, which would be 160. Some of you would say, well, that could just be 2 over 16. Yeah, but I need common denominators, right? So I'd have to multiply the 20 by 8 there as well to get 160 matching denominators. And then the numerator, 8 times 1, which is 8. So then I have in 1/60ths, 8 plus 20, right, in 1/160ths. So 8 plus 20, that's going to be 28. And let's see, this is should only be divisible by 2, but the calculator will tell us. It should be 14/80ths, right? Is that right? No, it should, yeah, you can divide by 4 in both of them, but 28 1/60ths. I'm just going to type this in the calculator. Enter. It simplifies it for us as 7/40ths. There we go. And as I said before, it's already a proper fraction, so it's impossible to change that into a mixed number. But I will check in the calculator, though. Yeah, the calculator confirms it. All right, I do like these types of problems because the denominators already match, and so there's no need to find matching denominators. Just be very careful because sometimes students, as basic as a fraction problem as this can be, sometimes students will kind of complicate it. They'll say 8 times 8 is 64, and then 3 times 1 there is 3. It's just, it would be okay if that was multiplication, but this is not a multiplication problem, right? It's just addition. And that's why I say it's nice that the denominators match, so we know we're dealing in eighths, but then you'd have 3 plus 1 there in the numerator, which is 4, okay? Just always be sure to simplify, just as it says right above there. These are both divisible by 2. If you need a calculator to do this simplification, don't worry about that. You're welcome to do it. It's just going to be 2. Oh, I put divided by 2. I should have put 4 to save me some time. Yeah, that'd be 1/2 right there. 1/2. All right, what about another division problem? And yeah, we got some more negative signs on this. And so, well, I'm okay with the -12. I just don't want the multiplication or the division right there. I do want to change that into multiplication, which is what I will do. It's just if I do that, then I need to reciprocate the fraction, right? Still negative. It's just now it's -4/9. And in addition to that, I'm going to change the 12 into a -12 into -12/1. And yes, there is some cross simplification here with the 12 and 9. They're both divisible by 3. So that'd be 4 and 3 right there. 12 divided by 3 is 4. 9 divided by 3 is 3. And now I'm ready to multiply the numerators. I'd have in the numerator 4 times 4 is 16. In the denominator 1 times 3, which is 3 16/3. And this is positive, by the way, because we had 2 negatives. So that's our improper fraction. You can change it into a mixed number if you'd like. I'm going to skip the calculator method just to save us a little bit of time. That's 5 1/3. Yeah, we can do this one too. And cross simplification is going to make this one pretty easy, which we'll show here. Of course, calculator would simplify this for you as well. Either way works. I see that the 5 and 35 can be cross simplified. They're both divisible by 5. 5 divided by 5 is 1. 35 divided by 5 is 7. And then in the 3 and 18, those are both divisible by 3 as well. 3 divided by 3 is 1. 18 divided by 3 is 6. Okay. And I probably should have done this earlier, but I know that my answer is going to be a negative. Well, how did I know that? It's because there was only one negative being multiplied right here, right? Negative times a positive is a negative, or you could say 1 is odd, so therefore you know your answer is going to be negative. But now I'm ready to do the actual multiplication, which should be fully simplified now. In the numerator, I got 1 times 1, which is 1. In the denominator, I have 6 times 7, which is 42. Now, for those of you that saw the big numbers and got really worried, like 18 and 35, yeah, if you multiplied 18 times 35, you're going to get a big number, but that's why I prefer cross simplification in the beginning. You could have multiplied and then simplified in the end. But as usual, I will check in the calculator here. So yeah, the calculator confirms that we've done that correct. All right, perform this indicated operation, and that's just, it's got the exponent, which means that I'm just going to show this with repeated multiplication, right? And we'll use some technology to kind of help us along. It's negative 3/4 times negative 3/4 times, yep, negative 3/4. There we go. So the first thing I would look at a problem like this is to say, well, what is the sign of my answer here? And I see there's 1, 2, 3 negatives. 3 is odd, so I know my answer is going to be negative, some kind of fraction right there. In the numerator, I got 3 times 3, which is 9, times 3, which is 27. So that's my new numerator. In the denominator, I've got 4 times 4, which is 16, times another 4, which would be 64. So this should be our final answer. And again, just as usual, we can use the calculator to check. Just if I do that, I'm going to type it in exactly like I see it from the beginning, right? So the calculator confirms that our answer is correct. So simplify the lowest terms, no problem. I see that 4 and 36, by simplifying this fraction, by the way, it's not going to change the sign. Still negative. But 4 and 36, they're both divisible by 4. So you could have divided by 2 and then 2 again. Of course, you could have just used the calculator. But 4 divided by 4 in the numerator is 1. 36 divided by 4 is 9. We get a negative 1/9. But let's write this one in lowest terms. So 42 over 78. I don't see anything that's common here. Maybe a 6 perhaps, but they're at least divisible by 2. So 42 divided by 2 is 21. 78 divided by 2 would be 39. Yeah, it looks like it. So yeah, these are both divisible by 3. I know I'm doing this 2 times, but whoops. You wouldn't necessarily need to with the calculator. 39 divided by 3 is 13. So yeah, that's as far as we can simplify this one. So write this one as a mixed number, no problem. We can just use some long division. And in fact, you can kind of start your answer there. I know it's going to be negative, and then we're going to have our fraction there. And the fraction part, the denominator will have a 3. I just got to do 44 divided by 3, right? Of course, the calculator would do this for you as well. 3 goes into 4 once. 1 times 3 is 3, so subtract gives us 1, drop to 4. 3 goes into 14 4 times. 4 times 3 is 12. When I subtract there, I get a remainder of 2. So, with my quotient being 14, that's the whole value in the mixed number, and the remainder 2, that's the numerator. That should be done. But let's check with the calculator. Calculator confirms that our answer is correct. Write this one as an improper fraction. Oh yeah, we like this with the cycle method, right? So that'd be, of course, we know the fraction is going to be negative because it started as a negative over here, right? But then I'd have, I got to find the numerator. We know the denominator is going to be 5. That's going to be 30 times 5 first. With cycle method, that's 150. And then finishing off the cycle to add 4, 154. So that's 154 fifths.